All right, and then 3.6 quadratic inequalities. Quadratic inequalities means quadratic, it's a quadratic equation. Inequalities means it's no longer an equation, there's no equal signs, they would have inequalities. So what does it mean by graphing inequalities? It means we're going to have these signs right here. This is, whoa, earthquake, stop that earthquake. Y is less than. This is y is less than or equal to. This is y is greater than. This is y is greater than or equal to. Okay? When you see these two signs here, that means you're going to shade below the line. When you see these two, it means you're going to shade above the line. These two, this is a less than symbol, this is a greater than symbol. That means the line itself will be dashed like this. There's an example of a dashed line. When you see something like this, where it's y is less than or equal, y is greater than or equal, means it's a solid line. Here's an example of a solid line. So this stuff, stop the video and put it in your notes. Copy this in your notes, stop the video, pause it, put that in your notes. This stuff as well, pause the video, put that in your notes. Alrighty then, that stuff goes in your notebooks. This stuff we have. So let me just get a little closer. A little closer. Here we go. So this is our parent function, y equals x squared. That's an equal sign. That means you just graph it like we have in the past. Stuff just like this. Okay? It's just, here's your curve. Your vertex is at the origin. It goes up. So 1, 1, 1, 3, 1, 5, 1, 7, 1, 9, so on. Here's your curve. For this stuff that we're going to do today, you do not need to write the vertex. You do not need the axis of symmetry. You do not need the axis of symmetry. You do not need to label a vertex. You just have to graph it. Okay. This is an equal sign. It's a solid line. There is no shading. No shading. It's an equal sign. That's an equation. There's no shading. These other things, there will be shading. So according to the stuff you put in your notes, is this a solid line or dashed line? Solid. Is it, you're going to shade above or below? Above. What about this one? Solid or dashed? Solid line. Are you going to shade above the line or below the line? Below. This is the stuff you're using, this stuff right here. This is what you're going to use. Okay? What are these stuff? Solid or dashed line? Okay? That's a solid line. Solid or dashed line? Solid. Solid or dashed line? Solid line. Okay, so we know that's a solid line. Do you shade above or below? Shade above. It's a solid line. Do you shade above or below? Below. This is the stuff that we're using. Okay? This one right here. It's a solid line. Do you shade above or below the line? Shade below. Okay? So now we have two inequalities. It's a solid line, you shade below. And we get down to here. Here's another. If this is, this would be a dashed line, and you shade below. This one, solid or dashed? Solid. Do you shade above or below? You shade below. For this one, solid or dashed? Dashed line, just shade above or below? Shade below. Solid line or dashed line? Solid, do you shade above or below? Above. For this one, oh, there we go. Solid line or dashed line? Solid, do you shade above or below? Above. Solid line or dashed line? Dashed line, do you shade above or below? Below the line. So now, so when you get something like this, you go, well, how do I graph that? Just think of this as an equal, think of it as an equal sign, just like this one, and graph it if it was an equal sign, like that. Okay, so you have that. Graph it as if it was an equal sign. So now this says this is a solid line, so that's a solid line. And it means you shade above. So I'm just going to where the vertex is. Anything I go above that. So anything above this side of the line, I'm going to shade. You either shade on one side or the other. There's only two, for this, there's only two spots you can shade. You either shade above it or you will shade below it. So here's the vertex, everything on this side. So this area right here, that area right there will be shaded. So I need to make it obvious which is the area that I mean. So I'm going to shade that in heavily so you definitely know this is the area that I'm talking about. Now what does that mean? That means any point in here, this value of x and y would make this a true statement. Same thing with that point, that x and y, and that point, and that one, and that one, and that one, and that one, and that one. Anything on the line itself would also make this a true statement. If I pick the point out here, x is 10 and y is 0, that would not be a true statement. X is 10, that's 100, that's 0. Is 0 greater than or equal to 100? No. Okay. What about these ones? Okay, you graph this just like it's an equal sign. Make your parabola just like it's an equal sign. Now you have to decide that's a solid line, so that should be a solid line. Now do you shade above or below? You shade below, so I'm going to go to the vertex and shade below. From that point down, this is the area that I'm going to shade, this side right here. Everything down on this side right here. Okay, so I need to make it obvious. What's the area that needs to be shaded? Make it obvious. Make it obvious which area needs to be shaded. It's all this area over here. All of this side. Remember, there's only two sides to this. It seems weird, but there's only two sides to this. Some people think, well, there's an inside and an outside. Sure. This is all one side. This area right here is a different side of that curve. When you get to this one, this is now negative x squared, which negative means it's going to open downwards. So here's the curve. There's our curve. Okay, we get that in focus. There we go. Hold on, there's the equation, inequality. Think of this as an equal sign. It's a solid line. Make sure that's solid. To shade above or below. You shade above. So I go to the vertex on this side. It's either this side or this side. It's on this side right here. This is the side I'm going to shade. Make it obvious. It's not obvious right now, so I'm going to make it obvious. This is the side of the curve that I want shaded. This is the side that needs shaded. Do some shading. Put it on the side. If you're an artist, you know you can do this to make it. If you've done art, you know you've done this. Get some shading going on there. So there you go. Okay. What this means is any of these points, that x and y value would satisfy that inequality. Same thing with that x and y value, and that one, 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 and that one. Any place in the line would also satisfy it. This point right here, that's not shaded, it would not satisfy that inequality. What about this one? Think of this as an equal sign first. Graph it. It's a solid line. You shade above or below? Below. Go to the vertex, shade down. It's this side. This is the side that's going to be shaded. So make it obvious. Make it obvious that this is the side that you want shaded. So if you're an artist, you know how to do this shading already with the pencil. There you go. This one. Oh, now we got two inequalities. It's a system. When you see when it says a system of inequalities, a system means it's going to be more than one. So it could be 2 or 3 or 4 or 5. We're just doing 2 right now. So we need to find an area that satisfies both of these. So the top one, this blue one, the top one. So that's why, think of this as an equal sign first. This curve right here, that's the blue one. I think that's the blue one. It's this, the top one, I know that. Okay, y is less than. Okay, it's a solid line, that's solid. Okay, it's less than, so anything below that. So I'm just gonna do this. It's on this side of the curve, on this side of that curve. This is the side that is shaded, that satisfies that one. Now I need to find This one right here, this is red, okay? The red one is right here. This is the red, the lower, this curve is that one right there. It's a negative, it opens downwards. And here's your vertex. You shade above, it's a solid line. That's a solid line. You shade below, so below that red line. So below the red line, this area right in here, below, 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 below. Which area satisfies both of them? Which area satisfies both? This area satisfies both, right here. This area does not satisfy, it satisfies this curve, but it does not satisfy that curve. So the only thing that's shaded for both of these is, you can make it obvious. Make it obvious, this area right in here. So this area, for some people, that's not obvious enough. Okay, well, I'm going to erase all this other stuff. Good thing you use pencil. That's a lot more obvious. Only this area right here satisfies both of those inequalities. Okay, this area, any point in the shaded region, that value of x and y would satisfy both of those. This value of x and y would satisfy both of those. This only satisfies this one. It does not satisfy that one. Okay, we have this. Again, you'd graph this as if that's an equal sign. So in this case, there we go, right there. This one right here is negative. This opens. It's this curve right here. It's a dashed line. That's a dashed line right there. Just shade above or below? Below. So right here, below, from the blue. This is the blue right here. That's this curve. So this curve, everything below. This area right here that I lightly shaded right now satisfies that one. For this curve, y is less than or equal to x squared. It's this curve. Okay, and you're shading below. So below that one would be this area. This area would satisfy that curve. So now which area satisfies both of those? So the only thing that satisfies both is this area right in here. So make it obvious. Which is the area that you want someone to know? This is the area that I'm talking about. That right there. I don't want that, and I don't want this. I don't want that. That's why that stuff you just want to do lightly. So now, this area. This area right here, this whole area right here satisfies both of those inequalities. It's below this one, and it's below this one. So that area would satisfy. Let's go to the next one. This one, we got two more and we're done. Okay, for this equation, it's that one right there. It's this curve, 2, 8. Remember, you have to find the vertex, negative b over 2a. Okay, it is a dashed line. That's dashed line. This is a dashed line. Dash, dash, dashed. And you shade below. So it's from the vertex, I'm shading below. So this area right here. This area right here is below that curve. So this area right in here. This one is that curve right there. It's solid line, so that's a solid line. Shade above, so everything above that. So which areas satisfy both of those curves is just this area right here. And for some people, that to me is kind of obvious, but I want to make it more obvious because I don't want to have anyone have second thoughts and go, well, did they mean this or did... Here, make it obvious, erase the other stuff. This area right here that's shaded, this, any place in the shaded region, that value of x and y satisfies both of those inequalities. Same with this value and that value and that value and that value. Any place that's shaded would satisfy both those inequalities. In this case, since it's greater than or equal, it could be on this line and satisfy both. For this one, if it's the dashed line, means if it's on the line, on the dashed line itself, it would not satisfy this. So in this case, if it's on that line, it does not satisfy it. It has to be below to be satisfying that equation. This one, you could be above or on it. And then we have this one right here. This one, this top equation is this one. It's a solid line. And we shade above. So right here, shade on above that line. It's everything on this side of that curve. Everything on that side of that curve. For this equation, it's this one right here. It's a dashed line. That's dashed, dashed, dashed. And shade everything below that. So everything from here on this side of that curve. All of that, 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 all of that. So what's the area that satisfies both of those? It's going to be that area right there. This satisfies the red, but not satisfies this curve. But it doesn't satisfy that one, so that area doesn't work. This area right here, it satisfies the blue, this one, but it doesn't satisfy that one. So let's get rid of this area. This area right here does satisfy both. So I want to make it obvious. Shade this area right here. Shade, 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 shade. Throw shade. Throw shade. No, throw shade. There you go. So don't make it obvious which one. There you go. So all this area right here. Either this shaded region or this shaded region. If I pick that point, that value of x and y would satisfy both of those inequalities. Any point in this shaded region, this value of x and y would satisfy both of those. Okay, that's it. See you next time. Bye, guys.